I started another recording. Can you please restate the problem? Which problems do you want?
Yes. So on page 224, the number is number 28.
Yeah, I will of the 10th edition of the 9th edition, right? Bluman
Yes.
9th edition.
The
Okay.
9th edition.
Yeah. Let's see. Let's go back to the problem. So it's just number 28, correct?
Yes, and it's part C.
Part C. Okay, let's just delete that. So, part C, it says congressional terms below is given the summary of from the 112th Congress of Senators whose terms end in 2013, 2015, or 2017. Okay, so it says choose one of the senators at random. Find number C. It says the probability that it is a Republican, given that he exercised his term in 2017. This line right here represents given.
Given.
Okay, that's just notation. Okay.
So it doesn't look like division, correct?
Mm-hmm. Yeah. I'm actually gonna let's see more. I'm gonna screenshot it. I want to because I want to. Oh, maybe I can actually just write on here. Yeah, I can. So it says, given that 2017. Oh, sorry. Given that he exercised his term in 2017, right?
Yeah.
So that means I can own this. Well, if we're just gonna do the conditional probability equation, it's basically probability that it was Republican and 2017, right?
Yes.
Divided by the probability that it was in 2017, because it's given 2017, correct?
Yes.
Here they gave us a table, as you can see, right?
Yes.
So given that's 2017, that means I'm only looking. Oh, sorry. That means I'm only looking at 2017. Do you see what I'm doing?
Yes.
Because it's conditioned, like it's given that it's only 2017. And I want to look at Republicans only. So I'm forgetting about Democrats for now. Okay?
Okay.
See this number 13?
Yes.
Oh, I circled it wrong. It's an overlap, right? Because both circles include it.
Yes.
So this is gonna be my and statement, right? It's gonna be 13 because it's both for Republicans and for 2017.
Oh, okay, okay.
Okay, so it's 13, and then the probability of me in 2017 is both of those numbers, right? It's this number and that number.
Yes.
So I just add them. So it's 13 plus 1, which is 14, correct?
Yes.
So that's gonna be my sample space, or the number of possible outcomes, or whatever, the denominator.
Okay.
Okay. So my answer would just be 13 over 14, which if I use the calculator really quickly, and will be, let's see, probability of 13 divided by 14. That's gonna give me 0.92. I don't know how many decimal points you guys need. 8.5 should be fine. Or 8.6. Sorry, 8.6.
Yeah, 8.6. Just because if you go to percentage, you want percentage to 2 decimal places.
Okay, yeah. So basically, if you're doing percentages, so you just multiply this number by 100 if you're looking for the percentage of it.
Okay.
Which would give you 92.86%.
Okay.
Does that make sense?
Yeah, so so at the top where it says and, so I'm not multiplying those two numbers, like Republican in 2017. I'm not multiplying those because I saw the word and, and I automatically thought I had to multiply those two
I understand that, but for this one, we're doing a table. So usually when we're doing tables, you just want to look for overlaps when it says and. You don't want to look for that for multiplication. This usually works when they give you just a bunch of probabilities, like the probability of Republican is this, the probability of being in 2017 is that, or whatever.
Okay.
You know? Yeah. Then you can do that.
Okay. That's where I think I got stuck in the problem where I thought I had to multiply it, and that's where I wasn't getting the number correct. Okay.
Oh, yeah, no, don't worry about it. But yeah, that's it.
Okay.
Do you have
Okay.
any other questions?
Just one last question with probability.
Okay, sounds good.
Okay. But it's a different thing.
Yeah, just tell me the chapter and I'll gladly help.
It's
Here.
just actually a question.
Oh, okay.
So,
Let me.
okay.
Yeah. So what's up?
Okay, so with probability, because my understanding is, whenever we see the word or, we add,
Mhm.
and then when we see the word and, we multiply,
Multiply.
and then
Yeah.
given is, I use that formula, the one that you just showed me. But what if like the problem doesn't have and um, or given in it? Like for example, like I could read one out of the problems which didn't have that, and
Mm-hmm.
I didn't know what to use, what formula to use. For example, like it says, if one has 3 dice, what is the probability of getting 3 4s?
If one rolls what? Two
Um,
die?
if one has 3 dice,
Okay, so 3 dice.
what is the probability of
Mm-hmm.
getting 3 4s?
Oh, like 3 4s? Three fours? Like so basically like a 4 on every die?
Yes.
Okay. Well, I mean the probability of you getting a 4, well, okay. So you can only get that in one way, right? There's not multiple ways for you to get a 4 on every single die.
Yes.
So it's gonna be 1 over your sample space, which is gonna be 6 cubed because you have 3 die. So 3 die, right? It's gonna be like 6 times 6 times 6. That's gonna be your sample space,
Yes.
which gives you 216.
Okay.
Okay. So basically, there's only one way from all the 216 outcomes that you can get 4, 4, and 4. So your probability is just 1 over 216.
Oh, okay. Okay.
Which is 0.00462 whatever. Okay?
Okay. Because since I didn't know like what to use, like either to add them or multiply them, I
Mm-hmm.
just I did parentheses, like I did 1/6 parentheses, then 1/6 parentheses. So I guess it ends up being
Yeah, that's the same thing. So
oh
because in multiplication, your numerator multiplies and your denominator multiplies. So 1/6 times 1/6 times 1/6 is just 1 over 216. It's the same thing.
okay. Okay.
But yeah, good job. That's good thinking.
Okay. Okay. I just wasn't sure when it said that, like if it didn't say that those
Mhm.
specific words.
You can actually make it like you can think of it as an and statement because you want a 4 and another 4
Oh,
and another 4.
okay.
You know what I'm saying? Yeah.
Makes sense. Yes.
So I would think about it if you want to do like and or statements.
Okay. Sounds
Okay?
good. Okay.
Thank you. Do you
Okay.
have any other questions?
No, that's all.
Okay. Thank you. Have a nice day.
You too. Thank you. Bye.
Bye.